Okay, I'm back. Variable names. Talked a little bit about this already. So we figured out A does not equal capital A. So that's one of the things to notice. It's what's called case sensitive. Oops, I didn't want to do that. A equals 2, big A equals 3. There. Little a equal. This is a comparison operator. Um, it does not equal each other. It's a logical 0 or false. Names, the names you define can start with a letter plus letters or digits, the digits 1 through 9, and or, and I meant to say or instead of, or letter plus letters, digits, or an underscore equals the name of something. So when you define names, it got to be like that. Case sensitive, just like we saw here, that a lowercase a does not equal an uppercase a. So if you have a capital letter and a lowercase letter and you forget that your variable has a capital letter on it and you type in the lowercase letter, then you'll get an error. You'll notice what Matlab did for NaN equal Na capital N. These two should be equal. They are, or they're false. It says false. That's weird. Take a look at that. Oh well. Um, that is really weird. I would have expected a true answer to that. The probably um, it's just the way they wrote the software in the background, which I don't understand. I don't know what they did when they wrote this command, when they wrote little nan and big nan. But it gives us a no, they're not equal to each other. Idiosyncrasy of the language. You expect it to be equal, but they're not. Don't get too frustrated with those kinds of things. You'll see them all the time. This is just one, and probably one you won't encounter most of the time. Okay, we've already encountered the word exist. E-X-I-S-T. Exist, not a number. That means it's a system variable. 5 does. If you want to find out what they all mean, just help exist. You're looking for zeros, and this tells you what type of name it is. It's a variable in the workspace. It's a file name. It's et cetera, et cetera. All the other stuff it can be, which we don't care about. We've already seen examples of comparison operators. So we've already got A and B in the workspace. So is little a, well, let's make a B. B equals 4. So is little a less than B? True. Is little a greater than B? True. Little a, we've already gone through a little bit of the not equals B. It is true that it's not equal to B. A equal B, double equal sign comparison, single equal sign set. This sets A equal to B. it will make little a, well, b is 4. It'll make little a, and take a look here. As soon as I hit return, it'll change little a to 4. This is putting the value of b into a. It's not a comparison. It's not asking, are they equal? It's setting a equal to b. It doesn't change. It makes a equal to b. It doesn't make b equal to a. It makes a, what's on the left, equal to what's on the right. In the old days, they used to say, they used to have a command out in front that said let a equal b. Those days have gone away, but that's still why we keep this notation. We just, why do I have to type let all the time? Let's just not even worry about it. Everybody knows what it means. Okay. Greater than or equal to works pretty much the same way. Less than or equal to, not equal to, and is equal to. Double equal. Is a equal to b? That's what this means. Is a equal to b? Helps. I already mentioned some of the helps already. You can search for something here. There's the question mark here. You can type help here. You can use Google. Use these. fx lets you figure out a function. If I wanted to find the sine function, for example. Now, it turns out the sine function is under elementary math. Mathematics, elementary math. Probably everything we're dealing with right now is considered elementary math. And the sine function is in there, it is, very first one under trigonometry. So sine of, what is the sine of 30 degrees? It's not that, is it? What did I do wrong? Pause, think about it. Okay. If we want the sine in degrees, we have to put a little d right there. That's sine in degrees. Otherwise, we're asking for the sine in radians. Let's see. You can get more help right here, by the way. I wonder if more help would help us, tell us it's radians. You know, it doesn't tell us radians, does it? But it gives us a hint. Take a look. So it gives us an example. The example is in radians, and voila, it works like it's supposed to. Sometimes it's not real obvious. Sometimes the help is not real obvious. You got to dig a little deeper. The help is written by expert computer programmers who assume that you know everything, and they forget stuff. Help systems are written like that. So again, try not to get frustrated. Use Google. Go someplace else. Try here. Oops. Here or here or here. We've already, or here. Let's see if that, oh, there. It tells us it's in radians right there. Here's sine D, second one on the list. Sine of the argument in degrees. Cosine, same thing. Cosine radians, cosine D in degrees, and so forth. Let's see, pi divided by 6. Pi over 6 is 30 degrees. Pi over 6 radians is 30 degrees. Okay, ladies and gentlemen, that's it for this file, this video. I'm going to pick up next time. We've gone through add, subtract, multiply, and divide.